Well, welcome. In this video, we're going to be looking at how we can use that central limit theorem that we talked about in the previous video, and how we can use that to determine probabilities. So you want to remember that to find the standard deviation of a set of sample means, what we do is we take the standard deviation for the entire population and divide that by the square root of the number of items we have in our samples. So basically what's highlighted here above me is really important to make sure you understand. This is the key concept for this lesson, is that if we know the mean and if we know the standard deviation for a sample space, we can determine how likely it is that a mean of a single sample of size n will be within a certain distance of the mean of the entire population. So again, in this lesson we're going to be looking at how far away the mean is from a particular sample from the mean of the entire population. So to help us see that, we're going to be looking at a story problem, and actually a couple story problems. But again, it's really important that we recognize that when we're dealing with a sample, we're dealing with a small amount, we have to find the standard deviation for the sample means, and that's going to be what we use as a standard deviation when we go to find the z-score, how far above or below, or how many standard deviations above or below a particular value is from our mean. So let's look at an example so you can see what we're talking about here. So here it says, in a certain country, the mean family income when converted to US dollars is known to be $13,500 with a standard deviation of $2,000. Suppose a random sample of 100 families is to be chosen. Let X bar be the mean family income of the sample. Determine each of the following. So we want to find the mean and standard deviations of the sample means. So recall that the mean for our sample means is going to be the same as the mean for our population, the $13,500. The standard deviation, that is what we were just talking about, where we have to take the standard deviation of the entire population and divide that by the square root of n. Well, 2,000 divided by the square root of 100, well, the square root of 100 is 10. So I would take the standard deviation for my population, the 2,000, divided by that 10, and I would get $200. So the standard deviation for a sample means would be $200. Now we want to find the probability that the sample mean is less than $13,000. So my first step is to figure out with that $13,000, how many standard deviations below the mean would that be? Well, so to do that I use my z-score. Now it's important to recognize my z-score here. Typically, we would take the value of the 13,000 minus the 13,500 and divide that by the standard deviation for our population, the $2,000. Well, since we're dealing with a sample, it's important that we recognize that we use this standard deviation for a sample mean, the $200. So when I do that on my calculator, 13,000 minus 13,500, and divide that by 200, I get negative 2.5. So my goal here is to find the probability that my z-score is less than negative 2.5. So to find if it's less than 2.5, we're going to use this table. So you should already have this printed out. You can access this from my website, or you can access this from anywhere on the internet. This would be the normal distribution, standard normal distribution table that we've been using in this chapter. So remember, negative 2.5 is not going to be on this table, but if we look at positive 2.50, we would get this number. We get 0.9938. Well, that represents everything to the left of 2.5. Well, to the left of negative 2.5, we would take and subtract that value from 1, which would give us 0.0062, which 0.0062 is the same as 0.62%. Now let's look at the next one. We want to find a probability now this time that the sample mean is between 13,300 and 13,700. Again, we're still dealing with the same sample size, so we would still use that 200 as our standard deviation for the means of our samples. So we take the 13,300, subtract that from 13,500, and this we could do without a calculator because this would give us negative 200 divided by a positive 200 is negative 1. So that represents that 13,300 would be 1 standard deviation below the mean. Let's look at the other one, 13,700. Subtract that from 13,500. That's 200 as well, divided by a positive 200 is going to give me a standard deviation of 1, meaning that the 13,700 is 1 standard deviation above the mean. Now we should be able to figure this out without using that table, because remember from the very first lesson that we talked about in this chapter, we said that when you're dealing with data that's within 1 standard deviation of the mean, you're going to be dealing with about 68% of your data. So in this case here, the probability that the sample mean is between 13,300 and 13,700, since that's going to be within 1 standard deviation of our mean, our answer would be about 68%. Let's look at another example. So this one here, it says, use the information that the heights of young adult women in the U.S. can be modeled by a normal distribution with a mean of 5 feet, 4.1 inches, and standard deviation of 2.6 inches. Now I want to make sure my units are consistent, and since my standard deviation is in inches, it would be best if I have my mean written in inches as well. So the 5 feet, 4.1 inches, well there's 12 inches in a foot. So 5 feet would be 60 inches, so add another 4.1 inches, we get 64.1 inches. So we want to find what is the probability that a sample of 50 randomly selected U.S. young adult women would have a mean larger than 5 feet 6 inches. So again, the 5 feet 6 inches would be the same as 66 inches. So I want to find how many standard deviations above the mean the 66 inches would be. But before I can do that, I first need to figure out what is the standard deviation for our sample means. So to figure that out, I would take the standard deviation for our population of 2.6, divide that by the size of my sample, which is going to be 50, square root of 50. Divide those two, and we get 0.368. So when I go to find these, how many standard deviations above my mean, 66 inches would be, 0.368 is what I would use for my standard deviation. So I would take 66 inches minus 64.1 inches, divide that by 0.368, and I get 5.16 standard deviations above my mean. Well, so basically what I'm trying to do is I'm trying to figure out what's the probability that my mean, or in this case my z-score, is going to be greater than 5.16. Now if you try to find that in the table, you are not going to see that, because your table, the largest it goes to would be 3.9. So it's 0.9990. So again, it doesn't go any higher than that. So we don't have 4 or 5 on here. So basically what that means is if we look at what our normal curve would look like, remember 99.7% of my data would be within 3 standard deviations of my mean. So as I get larger and larger, farther and farther away from my mean, we're going to get closer to 100%. Like for example, 5 would be almost, to the left of 5 would be almost 100% of my data. So the fact that we're trying to find the probability that my mean is greater than 5.16 standard deviations above my mean means that it's going to be about 0%. So very slim chance of that happening. So I want you guys to try this next one though on your own. So this time we're increasing the size of our sample to be 100 randomly selected U.S. and young adult women. So we want to find the probability that that 100, or that within that 100, your mean is going to be between 5 feet 3.5 inches and 5 feet 4.5 inches. So before you try this one, you're going to want to make sure that you change these inches to be, or 5 feet 3.5 inches to be completely in inches, just like we did in the previous one. And then you want to make sure you find the standard deviation for your sample size, or your sample means. And then once you have that, then you'll be ready to find these two z-scores and look those up on the table to figure out the probability that the mean is going to be between those heights. So go ahead and pause the video and hit play when you're ready to check your answer. Okay, so you should have had an opportunity now to try that, so let's see how you did. So our first step is to figure out what is the standard deviation for our sample means going to be. So we would take 2.6, this time we divide by the square root of 100, which is 10, which gives me 0.26 as the standard deviation for my sample means. So let's look at that 5 feet 3.5 inches, which would be the same as 63.5 inches. We would subtract that from our mean of 64.1 inches and divide that by the standard deviation for our sample means, 0.26. When you do that, we get negative 2.31. And then we would do the same thing for the other height, the 5 feet 4.5 inches. That's the same as 64.5 inches. Subtract that from 64.1 and divide it by 0.26, which gives me 1.54. So that would be 1.54 standard deviations above the mean. The other one is 2.31 standard deviations below the mean. So we want to figure out what's the probability that our mean or that our z-score would be between those two values. So on your table, we would take 1.54, that value, subtract it from the value of negative 2.31. And those two values would be 0.9382 and 0.0104. So we subtract those to get our answer of 0.9278, or you could say about 92.78% chance of our mean being between those two heights. So there it is. That's all there is to this lesson. So again, very similar to lesson 11.3, where we did some of the same process. The only difference is that we're dividing by the standard deviation for our sample means as opposed to the standard deviation for the entire population. So hopefully that made sense to you. So good luck now as you work on your assignment.